Okay, set notation and absolute value are the two topics I got to talk about in this video. Set notation, sorry, I should erase this, is, well, first of all, a set is a group of any numbers or things. So like in this case, this is a set of the numbers 1, 2, 3, 4, and 5. Notice that they are surrounded by the curly brackets. That's what surrounds a set. And sets are given capital letters as names. Okay, so that's one way. Another way is to listen, kind of explain what's happening. Notice capital letter and curly brackets on either side. Whatever comes before this bar right here, that's going to be your variable. And then whatever comes after the bar is going to be what numbers or what things are included in that set, and they're going to describe them in mathematical terms. So if 1, 2, 3, 4, and 5 are in the set, we may say that they're integers. We could even say maybe they are natural numbers, and they're between 0 and 6. Notice there's no equal to, so 0 and 6 aren't included in that set. Okay, so that's notation. There's two different kinds of combinations, I guess, you can make with sets. You can make a union. A union is represented by a U. Oh, that's a terrible U. It looks like this. Okay, and basically you just combine everything together. If something's repeated, you do not write it twice. You just write it once. Make it one big group. An intersection looks like this. So I always think U, union, intersection has an N, looks like this. An intersection is where they're similar, where they cross, what is contained in both sets. Okay. So if I have set S, set T, and set V, if I want to find the union of S and T, I'm going to combine this and this. So I have 1, 3, 5, 6, 8, 9, and 10. That's the union. Intersection of S and T. So this would only be what is the same. That would be 6 and 8. And then S intersected with V would only be nothing. So you write it as an empty set, or you write it like that. Either way would be perfectly fine. That's my little blurb on sets. Okay, absolute value. I'm going to explain this a little bit, and then we'll do a couple examples. So we all know absolute value always gives you a positive answer. Well, why does it give you a positive answer? Because the definition of absolute value is the distance from 0. So if you have the absolute value of 6, we know that is 6 because it is 6 units from 0. Or if we have absolute value of -6, we know that that is also 6 because -6 is 6 units from 0. It's just to the left in this case. So this piecewise function explains how you figure out what the absolute value is if you don't have such a nice number like 6 or -6. So it all depends on if that number, that A in the absolute value, is positive or negative. So in this first case, 6 was positive, so I'm just going to get an answer of A, or 6. In my second case, A was negative, so I would have to do -6, which we all know is 6. So just to clarify, if the number in the absolute value is bigger or equal to 0, it's just that number. If the number in the absolute value here is less than 0 or negative, then you have to negate what's inside. For example, square root of -9, that would be -9 or 9. This one, your 4 is in the absolute value, so it's just 4. That's bigger than 0. So this would be negative 4. This one down here is where the issue always comes into play. We want an exact answer, so that's why we leave it as square root of 2. So square root of 2 is like 1.414. If I subtract 1 from that, I'm still going to get a positive, approximately 0.414. That's a positive number. So I have a number bigger than 0 inside the absolute value. So it's just going to be what it is. I don't have to worry about negating it. When I get down to something like this one, if I have pi minus 10, well, we all know pi is like 3.14. And when I subtract 10 from that, that gives me a negative number. So, since the number inside of the absolute value is negative, I need to negate the number. So the absolute value is going to be negative pi plus 10. Or you may see it as 10 minus pi if they flip it around. All right, see you tomorrow.